Okay, today I'm going to explain how everything can be manipulated with frequency. So in one of my previous videos, somebody said, "That's so crazy, you can send electricity if it's tuned correctly," and my response to them was, you can actually manipulate anything you want with frequency. So now I'll go ahead and show that comment. So now I'm going to explain what I mean by this. So we have atoms and molecules making up everything. So atoms are positive and negative charges, protons, neutrons, electrons, which means they're electricity because charge is electricity. So everything, therefore, is electricity. So electricity, unless it's direct current, it vibrates in some way. So that means it has a frequency. So everything must have a frequency. So, proof of this concept is, for example, an opera singer will sing and shatter a glass at its resonant frequency if they sing at the right frequency and the right amplitude. They can shatter the glass. Another example, if we have two tuning forks tuned identical to each other, or made identical to each other, like for example, we have two tuning forks of the frequency 432 hertz, and we hit one of them and one is right next to it, we can make the other one vibrate without even touching it. That's just a few examples. Another good example of frequency is, say you're wanting to listen to an AM radio station. Let's just say AM for now, amplitude modulation. Say you're wanting to tune in to 1,000 kilocycles or 1,000 kilohertz. Do you know what that kilohertz means? It means 1,000 hertz. So hertz is, well, for example, your house current is 60 hertz if you live in the U.S. Another good example of this is radio. So say you're wanting to listen to AM, amplitude modulation, which means it's modulating the amplitude of a wave. But anyway, so say you're wanting to listen to 1,000 kilocycles or 1,000 kilohertz. Well, kilohertz means 1,000 hertz. So anyway, that's a frequency. So, okay, so 1,000 kilohertz would be roughly 1 million hertz because you do 1,000 times 1,000 because kilocycles, and there's already 1,000 in front of it. So that'd be 1 million hertz. So say you want to listen to that radio station, well, you're tuning into a frequency. So in order to tune into the frequency you want with radios and stuff, you use what's called an LC circuit or tank circuit. Now I'll show you the definition of an LC circuit, but it basically means an inductance capacitance circuit. Okay, now I'm going to share something very interesting. So our power grid, from the municipal generators all the way to our house, pretty much everything in the U.S. To get electricity to our house and what we use is 60 hertz. So 60 hertz alternating current. Did you know that radio waves or radio frequency or RF, whatever you want to call it, the stuff that goes from your broadcast station to your radios, the stuff you listen to on your radios, is actually alternating current as well. When alternating current reaches a frequency of between 20,000 hertz and 300 gigahertz, it's considered RF, or radio frequency. So yes, you're listening to wireless electricity on your radios. It's not the most efficient way to do it, but it works. There is more efficient ways to do this. So here's another interesting fact. Did you know that we see in wavelengths and light is in wavelengths? There's plenty of other examples of wavelengths, but did you know that wavelength can be converted into frequency? Now I'm going to show you an interesting demonstration. So here I have a diathermy machine. It's from the 1930s. I've already plugged it in. So it's using 60 hertz alternating current. It uses 110 volts at 6 amps, so roughly 650 watts of electricity. Anyway, okay, now I'm going to do my demonstration. I'm actually going to be setting y'all on this music stand so that it doesn't interfere with my phone. Also, before I do this demonstration, I would like to tell you what's going on. Okay, so first, I will touch a metal object to the cauterizing terminal on the diathermy machine, and you will observe that there are only about an inch long sparks. Then, after I do that, I will connect this coil to that cauterizing terminal, the bottom of this coil I wound, which, by the way, this coil is wound up to 1/4 of the wavelength of the frequency coming out of this diathermy machine. The frequency on this diathermy machine is about 29 megacycles. So this is 1/4 wavelength of 29 megacycles. So this will act like as a guide, basically, for the electricity. So I have wound this coil to 1/4 of the wavelength of 29 megacycles. This works best with this situation. Actually, with this situation, a half wavelength, a full wavelength, and a quarter wavelength work best in this scenario right here. But if you're doing something else with frequency, like say you're not dealing with this electricity like this, you might find other wavelengths that work better. Okay, now we'll do the demonstration with the phone on this music stand right here, so that this hopefully won't interfere with the phone. Okay, here I have a knife. I'm going to turn this on and observe the inch-long sparks. Then I will connect the coil and then observe the sparks. Okay, now I'm going to connect the coil. And I've added this little metal thing on the top. This acts as a capacitor to tune this as well. Okay, let's connect this. Okay, it's connected. I hope, here, let me bring y'all in to see the connection. Okay, there it is. I'm not going to flip my camera because it'll stop the video and I don't want to. Anyway, there's the connection. That's the only connection. Okay, let me put the phone back over here. Now watch this. Now that was just one example of what you can do with one certain frequency. Now with the right combinations of frequencies, or the right frequency, or the right combination of frequency and harmonics, anything is possible. And that's what Tesla means, Nikola Tesla means by his quote, the key to the universe is energy, frequency, and vibration.